Okay, so solving systems algebraically, right? I mean, we've seen some limitations on graphically, which is if you don't get a totally accurate graph, or if the intersection isn't at nice integer values, it can be hard to tell. But solving algebraically, it won't be hard to tell, right? I mean, you'll know, and you'll have a solution. So what do? Here's what we do. You're going to be given two equations. So a system of equations is two equations, right, with two unknowns. At least two. It could be three equations with three unknowns, or four equations with four unknowns, or 157 equations with 157 unknowns, at which point you want to haul out a computer to solve those, right? So you can get some fairly complicated systems of equations that describe stuff. Anyways, solving system of equations. So we're going to have two equations. What we want to do is this. Step number one. Get a pen that writes. Given two equations, solve one of the equations for one of the variables. So generally it's either x or y, which brings up why y, probably just because it's after x. Solve one of the equations for one of the variables. So what you're looking for is you're looking for a variable that's got a coefficient of 1 already, right? We don't want to solve an equation. If you've got a 3y in there, we're not looking to solve for that, right? If you got like 3y plus x, we would solve for the x, not for the y. So solve one of the equations for one of the variables. Step two is substitute, hence the name of this method. So substitute into the other equation you'll now have an equation in only one variable, right? Solve that equation. And then you're going to go back and you're going to you're going to substitute into one of the original equations. So we can lose the sound, eh? One of the original equations to solve for the other variable. Solve for the other variable. Okay, so one of the equations for one of the variables, let's add a little something to it, right? You know, with a coefficient which has a coefficient of 1. Alright, so we get two equations. We solve one of the equations for one of the variables, right? You may have a choice, okay, depending on the equations and the way they're set up. You're looking for basically a variable with a coefficient of 1. So that's the first thing. If all you see is, oh, equation 1 has a single x, then that's and everything else has numbers, then I'm going to solve for x. You substitute it into the other equation, you solve that equation, you substitute back into one of the original equations to solve for the other variable, and and then you state your solution, let's say. Okay, and then state your solution. Also, you might want to check it too, right? Okay, so that doesn't hurt to check things over. And the check can be formal, left side equals, right side equals, or the check can be informal, just, okay, if I put a 2 in there and a 3 for this, yeah, that works, and yeah, that works. Right, because remember, how do we verify that a point is a solution to a system? We make sure that it's that it makes each equation true, right? We substitute in and say, is this true? Yeah, 5 equals 5. Is this true? 7 equals 7. Yes. A point is on a line if it makes the equation true. Okay, let's do it. So here's the equation. X plus 4y equals 6. And the second one is 2x minus 3y equals 1. All right, so what would we do yesterday? Well, yesterday we would rewrite the first equation as y equals negative 1/4 x plus 3/2. And we would rewrite the second equation as y equals 2/3 x minus 1/3. And we would graph those, and we would go second calc intersect, and we would find the x coordinate of the point of intersection, right? Well, no, we'd find the coordinate. We want that point. We'd find the point of intersection. But we're not going to do that. So we're going to call this equation 1, and we're going to call this equation 2. All right, and so I'm going to write out in detail. And I don't expect necessarily the same detail from you when you're solving, okay? But you may want to do this, but you don't have to. So here, I'm just going to explain what I'm doing, right? I'm going to solve equation 1 for x. All right, so I'm looking for the variable that has a coefficient of 1. There's only one of those, which is the x in equation 1. So we're going to solve 1 for x. Okay, so here we go. X plus 4y equals 6. X equals negative 4y plus 6. Or you could write 6 minus 4y. Okay, nobody really cares. That's it for step 1. Right? Solve one of the equations for one of the variables. Next, we're going to substitute. So what this says, an equal sign says, whatever's on the left-hand side is the same as whatever's on the right-hand side. So wherever I see an x, what can I do? I can substitute negative 4y plus 6. Right? Which you might want to write as 6 minus 4y with, oops, great, move the frame. Which you might want to write as 6 minus 4y. Okay, so we are going to substitute negative 4y plus 6 for x in equation 2. All right. Again, I don't expect you to necessarily write that out, right? But that's the explanation for you. So when you're looking at this, you can say, yeah, okay, I see what's going on, right? You're solving equation 1, etc. All right, so I'm going to rewrite. So I have equation 2, right? Equation 2 is 2x minus 3y equals 1. So instead of x, I'm going to write negative 4y plus 6 minus 3y equals 1. Okay, as far so good? Right, we just substituted for x, right? Because x and negative 4y plus 6 are the same thing. That's what the equal sign says. Extend the pin. Okay, negative 8y plus 12 minus 3y equals 1. Negative 11y plus 12 equals 1. Negative 11y equals negative 11. Y equals 1. You don't need to do all of that, right? But, you know, whatever you feel comfortable with, just something along those lines, right? You should show at least the negative 8y plus 12 minus 3y equals 1. And if you want to go to negative 11y equals negative 11y equals 1, you know, and we will ask you solve this by substitution, right? So we will specifically say you must solve this by substitution. Later on in the unit, it'll just be solve this, right? Whatever way you want, non-graphically, whatever non-graphical way you want. We'll just say solve algebraically. Okay, what's next? Well, then we're going to substitute 1 for y in which equation? Equation 1. Your choice doesn't matter, but in this case I think equation 1 is simpler, right? Because it has the x by itself, which means all we're going to do is stick the y in and then multiply it and move it to the other side, and life will be good, right? So equation 1 was x plus 4y equals 6. So it becomes x plus 4 times 1 equals 6, which is x equals 2, and the solution is the point 2, 1. Right? Remember, our solution to a system is an ordered pair. It's a point on the graphs, right? So we graphed these, and you know, if we'd done this graphically, we would have found the intersection point was 2, 1. Okay? Now, if you wanted to check this, right, an easy way to check this is, let's go to decimals. Let's clear out some stuff here. Oh, wait. Launch cap. No downloads, no special hardware, no working with the smart board. Wait, I will go into projection mode. There, things get big and bold. The nice thing about decimals is I can just type in the equations as they are, right? I can just type x plus 4y equals 6. And I can hit enter, and I can type 2x minus 3y, 2x minus 3y equals 1, right? And then I can say, show me the points. Where's the thing that says show me the points? All right, I can click on the point. So there's the point 2, comma 1, right? That's a point of interest, which is our point of intersection, okay? How do you verify that algebraically? Well, you put in a 2. So 2 plus 4 times 1. 2 plus 4 is 6. Yep. And 2 times 2, 4 minus 3 is 1. Yes. Okay? So an algebraic check, just substitute in your x and your y. If you're not asked to formally show it, as in we say solve and verify, then you don't have to. You should still, however, verify, but just do it mentally or graphically. Right? I mean, this is easy to do graphically, right? You don't have to rearrange anything. Unfortunately, you don't have access to this during a test, but you know, it's a handy thing. You can use it at home. So if you're at home sitting there and you know your computer's handy while you're doing your homework and you want to just graph it, so what do these look like? Right? What does this system look like? Okay, where was we? Oh, there we are. Right. So the solution is 2, 1. Okay, let's do another one. Because that, I mean, we could have solved that graphically, right? I mean, we could have graphed that just on graph paper without a calculator. We could have graphed it on graph paper, found the solution, right? Because it's a nice integer solution, but what if they aren't? Okay, and the problem is, and the problem some of you may have run into on the test yesterday was, you were trying to read numbers off a graph where you shouldn't have been, right? Like you were trying to say, oh, that's 5 1/3 when it was 5 2/5 or something, right? So if you're reading numbers off a graph, if you're reading points on a line off a graph, make sure that you're only reading points that intersect grid lines, right? Don't try and read off of, oh, I think that's 4 1/2, because maybe it isn't, right? I mean, maybe it's 4 2/3. You can't tell it's necessarily between 0.5 and 0.67 when the graph is that close together, right? If it's not a big scale. So choose intersection points. If you're looking for 2 points to like get the slope and to do the point-slope form of the equation, choose grid intersection points, use them. You can just count the slope, right? Go up 3 over 2, and then you can use one of those points. All right, but let's do another one. 5x minus 3y minus 2 equals 0. This is a general form equation, right? And 7x plus y equals 0. So they're both general form equations, right? So we look at it and we say, which equation, well, I better number them. So let's call this 1. And let's call this not 1. Yep. Solves, okay, so what am I going to write down? I'm going to solve equation 2 for y. Right, exactly. So I'm going to write that down. And actually, when I do a solution by substitution, I usually actually do write this line down. Right, solve equation 2 for y. Right, it's good communication, right? You're just communicating. Anybody that's looking at your solution, you can say, okay, this is what I'm doing. I'm solving equation 2 for y.
So on the test, will we be asked to like solve it by graphing or like just algebraically?
Kind of answer that already? Well, maybe not exactly that. Yes. The answer to your question is yes.
Okay, so on both graphically and like both ways basically.
Yes. Okay. So we will ask for a graphical solution. If we do, then we usually say round it to the nearest hundredth, right? Because some things don't have to be exact values, right? I mean, you're designing something, whatever, you're going to build something. You don't measure out to 74 decimal places when you're building whatever, even the finest instrument that you're you're building, right, we only go to a number of decimal places. So yeah, it's okay that the real world can have an effect where, you know, root 2 is not a good value for the length. You know, don't walk into Home Depot and say, I need something that's root 2 meters. You need a 2x4 root 2 meters long. Just gonna look at you, right? Because they didn't make it through math, that's why they're working. So you go in and say, I need one that's 1.41 meters, yeah, which is getting a little precise, right? I mean, but if that's what you have to cut it to, you're probably only cutting to the nearest centimeter, right? Or you might go a little bit, you know, because you got the width of the blade and all that. You got to figure out, are you building a piano or a deck? I mean, you know, decks don't have to be totally. Piano is a little more precise. All right, 7x plus y equals 0. So what's y equal to? Negative 7x. Okay, then we are going to substitute negative 7x for y in equation 1. Because putting it into equation 2 just ends up with 0 equals 0, which, while true, is not very helpful. Okay, so substitute, which is the name of the method of solution. Substitute negative 7x for y in the other equation, right, in equation 1. Okay, so equation 1 was 5x minus 3y minus 2 equals 0. 5x minus 3y minus 2 equals 0. So 5x minus 3 times negative 7x. So you notice at this point we have an equation in only one unknown, right? Just in x. Yep.
On the test, do we have to write down like the substitute for?
No, I'd write down the first one where I say solve equation whatever for whatever. Right? Just because, but it's kind of obvious. You know, but sometimes you guys don't show enough, right? And I look at it, like when you get this back, you may be looking at something and saying, well, yeah, I got like a half a mark for this, but it's right, and it's, you know, well, but what's shown there, and you know, there's stuff kind of all over the place, right? Like really, I work kind of top to bottom, left to right. So I expect if you're going, I expect you're going to start on the left-hand side, you're going to kind of go down, and then if you need to continue, you're going to move to the middle and go down, and then you're going to move over and go down, right, if you need more. If you need much more than that, then write it out on a sheet of scrap paper, right, and then just reference it. Say, see the scrap paper for this. But you guys, like, stuff's all over the place, right? And I got to try and figure that out. I'm not really that dedicated, so, you know, it's like, well, it's not, you know, if I just give you 0 on this, if you think it deserves marks, you can come see me and explain it to me. Right? And if you can't explain it to me, then, okay, obviously it deserved that 0 or whatever, right? Or 1 out of 2. Like, why did I get 1 out of 2? I got everything. Yeah, but I don't know how you got it. Right? There's no justification for why this is 13. It just is 13. Right? Which is the correct answer, but that just means you guessed it and then you stuck it in there and said, hey, look, it works. You know? Guess and check takes you so far, but it's not a good solution. All right, what do we got next? 5x. Plus 21x minus 2 equals 0. So what do you got? 26x equals 2. What's the exact value for x? What's the exact value for x? 1 over 13. Okay, so when we say exact values, we mean that it's either got a radical in it, simplified radicals. We mean that it's a fraction, not a mixed number. I don't want to see like 5 and 7/8. Okay, I want to see 47 over 8. Okay, 5 and 7/8, well, equal to 47 over 8 isn't useful if I then have to use it in a later calculation. I can't do much with 5 and 7/8, right? We stopped doing mixed numbers back in grade school, I think. Right? Like, really, that's when you did stuff like, ooh, what's 3 1/4 plus 2 2/3? Yeah, you know, and then it goes over 1, and I've got to do this and that, right? It's a pain. So we don't do that anymore. We want exact value. So when I say exact value, I'm looking for a fraction. I gave you the decimal, right? If you put like 7.3 with the repeating bar over top, I gave it to you. Don't expect me to give it to you in the future. Okay? I do not want decimals, unless they are really exact, like 2.5. If it's a repeating decimal, give it to me as a fraction. Okay? So 7 1/3 should come out as 22 over 3. Although that was actually negative 22 over 3. In the real thing. Okay, now what? So now we're going to substitute. I'm just going to extend it here. So we're going to substitute So actually, whatever method we're using, and the other method is called elimination. In the elimination method, this first step is different, right? You do something, you solve for a variable. Once we have solved for one of the variables, from this point on, no matter what algebraic method you're using, it's exactly the same. Okay? So we're going to substitute 1/13 for x in which equation? You choose, I don't care. It's going to work out the same either way. 1? Okay, so what's equation 1? Equation 1 was 3x minus, really?
2.
Really? 1? Yeah, you do 1. I'm doing 2. That's. Come on. You got to look at this. There's no numbers involved. I throw a 7/13. It's like y equals negative 7/13. I don't even need to write it to know what it is. But are you going to get negative 7/13 out of equation 1? Yes, after you change the 2 into 26/13. And then you multiply the, think. This is why you run out of time on these things, right? You're not thinking, oh, I'm just going to go into this one. I'm going to put it into 1 just to show you the pain. All right, what do we got? 5x minus 3y. Okay, 5 times 1/13 minus 3y minus 2 equals 0. 5/13 minus 3y minus, let's call this 26/13 equals 0. Negative 3y is equal to 21 over 13, right? I just combined those into negative 21 over 13 and then moved it to the other side. So y is equal to 21 over 13 times negative 1/3, negative 7 over 13. Wow, that was like fun, because if I'd have stuck it into, number 2, I would have had the answer. I already had the answer, right? I could just by inspect. So I'm going to show you. What if we put it in number 2? Substitute 1/13 for x in 2. Okay, what was 2? 7x plus y equals 0. 7 times 1/13 plus y equals 0. Y is equal to negative 7/13. Oh wow, that was hard. There's your solution. Okay? Yes? No? I made a mistake? Twice I made a mistake? What's your question?
Okay, so what's the difference between 1 and 2? Can you do it in either, or it has to be 2? Because it's the same.
You get the same y value. What's the difference? 6 steps compared to 1. What's the difference? Good chance to make a mistake. What's the difference? You got to change 2 into 26/13. You have to add that, negative 26/13. You got to subtract, you got 5/13 minus 26/13 that you have to work out. And then, not only that, but you get to multiply a fraction by another fraction. What's the difference there? You move positive 7/13 to the right-hand side, where it becomes negative 7/13. And you go, wow, I'm glad I chose this equation and not the other equation.
Just basically just choosing the easier.
Yeah, that's like no-brainer, and that's like a good chance for making a mistake and getting it wrong. And the problem is, it's not easy to check 1/13 and negative 7/13, right? If you do want to do it algebraically, and when you check, we always go back to the original. Why? Because if you make a mistake in doing your rearrangement, right? So when you solve the equation for the variable, if you make a mistake doing that, you will have now created a brand new system, which will have a different solution from the original system. So when I go to verify, I want to go back to the original system, right? And this will give me 7/13 minus 7/13, which is 0. And this will give me 5/13 plus 21/13, which is 26/13, minus 2, which is 26/13, which is 0. So it does check, right? So you need to check in the original, because if you make a mistake, like say at this point here, right? If you went y equals 7x, right? Little mistake. Then you've now created a different system. And you solve that. When you go, if you go back into here to verify, you're going to verify the solution to the new system you created, which isn't the system you were supposed to solve, right? So it'll be wrong. So you need to go back to the original system, okay? If you're going to verify, right? Do a left side, right side, or whatever. And again, you could do this graphically too. You could verify it graphically. Then you're looking to say, okay, it says that x is point whatever the decimal equivalent of 1/13 is, right? And you got to then check that. But okay. Any questions? I think that's really about all we've got for it. It's solving by substitution, not hard, right? So solve one of the equations for one of the variables. Make sure that the variable you're solving for has a coefficient of 1. Okay? All of these will. There will be at least one coefficient of 1 in the system. When we get to situations that don't have that, that's where we'll use the method of elimination, which we're going to learn tomorrow. All right, so while you're doing that stuff, we'll give you back your quizzes. And we'll get